So what exactly is an isotope? In this video, we're going to talk about isotopes. Now, instead of giving you a definition, I'm going to illustrate it with an example. Consider carbon-12 and carbon-13. These two substances are isotopes of each other. As you can see, isotopes are composed of the same element. Both of these atoms, they're carbon atoms, so chemically speaking, they react the same way. Now, the number that you see here is the mass number. Carbon-12 has an atomic number of 6. The same is true for carbon-13. The atomic number of an element identifies the element. So carbon will always have an atomic number of 6. So Z represents the atomic number. So when you look at a periodic table, you're going to see two numbers. The smaller of the two numbers is the atomic number, and the larger of the two values is the mass number. So isotopes, they're composed of the same element. In this example, both isotopes are elemental carbon. If the elements are different, then you don't have an isotope. Isotopes also have the same atomic number because the element is the same. However, they differ in the mass number. So isotopes will always have different mass numbers. Now the question is why? The answer lies in the nucleus of the atom. The nucleus of an isotope, or of two isotopes, are different. It's not the same. The atomic number tells us the number of protons. The mass number is the sum of the protons and the neutrons. So both carbon-12 and carbon-13 have an atomic number of 6. So therefore, the number of protons is 6. The number of electrons will be the same. It's 6 as well. For a neutral atom, the number of protons and electrons are equal to each other. Now, the number of neutrons, to find it, subtract the mass number by the atomic number. 12 minus 6 is 6. So carbon-12 has 6 neutrons. Carbon-13 has 13 minus 6, or 7 neutrons. So the reason why the mass number is different is because the number of neutrons are different. And so isotopes, they have the same chemical properties because they're composed of the same elements, but they exhibit different nuclear properties. Some isotopes are not active on a nuclear level, while others emit radiation. Some are harmless, some are harmful. So the nuclear properties are different, but the chemical properties are the same. So if you're studying for a test, here are some key facts that you want to remember. Isotopes are always composed of the same element. So remember that the element can't be different. It has to be the same element. Isotopes are similar to each other in that they have the same atomic number. And as a result, they share the same number of protons. Isotopes differ from each other because their mass numbers are different. They have different mass numbers, and also they have different numbers of neutrons. So remember that isotopes, they have the same number of protons, same atomic number, and they're composed of the same element. But they have different mass numbers and different numbers of neutrons. And isotopes share the same chemical properties, but they differ in nuclear properties. Their nucleus behave differently because the number of neutrons is different, which exists in the nucleus. So those are some key ideas that you want to keep in mind when dealing with isotopes. So let's work on a few questions that will test your knowledge on isotopes. So let's look at substance A and substance B. Now, just because the letters are different doesn't mean that the elements are different. So A and B could represent the same element, or they could represent a different element. Use the numbers to figure out which is the case. So let's say substance A has an atomic number of 12 and a mass number of 29, and substance B has an atomic number of 13 and a mass number of 30. these two substances, are they isotopes of each other? The answer is they're not isotopes of each other. Isotopes must have the same atomic number, which means they must be composed of the same element. Because the atomic number is different, the elements are different, and so these are not isotopes of each other. Now let's compare substance C and substance D. Let's say substance C has an atomic number of 15 and a mass number of 32. And substance D has an atomic number of 15 and a mass number of 33. Are these two substances, are they isotopes of each other? The answer is yes. They share the same atomic number, which means that substance C and D are composed of the same type of element. However, the mass number is different, and so therefore the number of neutrons will be different. So substance C and D are isotopes of each other. Now let's work on this problem. I want you to write the atomic symbol for each situation. So if there are 7 protons and 8 neutrons, how can you represent this isotope using an atomic symbol for it? So the first thing you want to do is find the atomic number and the mass number. The atomic number Z is always equal to the number of protons. The mass number is the number of protons plus the number of neutrons. So that's going to be 7 plus 8. So the mass number is 15. So whenever you're writing a symbol, you're going to have the element, the mass number, and the atomic number. So we have an atomic number of 7, a mass number of 15. Now we need to identify the element. Well, how can we do that? The identity of the element depends on the atomic number, or the number of protons. So what you need to do is you need to get a periodic table and look for an element with an atomic number of 7. That's going to be the smaller of the two numbers that you'll see in the periodic table. So this has to correspond to nitrogen. Nitrogen has an atomic number of 7. So this is how you can write the atomic symbol of an element or an isotope if you're given the number of protons and neutrons. So go ahead and pause the video and do the same thing for parts B, C, and D. So let's focus on part B. The atomic number, as we said before, is the number of protons, so Z is 11. The number of neutrons is 13. So the mass number is going to be the number of protons plus the number of neutrons. 11 plus 13 is 24. So using this process where we're going to put the mass number on top, the atomic number on the bottom left. So we have an atomic number of 11 and a mass number of 24. So now go to the periodic table and identify the element that has an atomic number of 11. This is going to be sodium. So this is the answer. It's sodium 24. The most common isotope of sodium is sodium 23. The atomic mass of sodium is about 22.99, which means the most common isotope is sodium 23, but there could be other isotopes, sodium 22, sodium 24. It's just sodium 24 is not the most common isotope. Now let's move on to part C. We have an atomic number of 14, so that's our Z value, and the number of neutrons is 15. So the mass number is going to be 14 plus 15, which is 29. So we got a mass number of 29 and atomic number 14. What is the element? So this has to correspond to silicon. Silicon has an atomic number of 14. So this is the answer for part C. Now let's move on to part D. The number of protons is 9, so that's Z. The mass number is 10. So what we have is 10 and 9. An atomic number of 9 corresponds to fluorine. Now this is a rare isotope because it means that it only has one neutron. So it's not a stable form of fluorine. But based on the information we have, that's going to be the answer. So now you know how to write the atomic symbol for an isotope if you're given the number of protons, neutrons, or the mass number. Now, let's test your knowledge on facts about isotopes. So here we have a video quiz. and it's a true or false quiz, so feel free to pause the video. Number 1, the atomic number is equal to the number of protons. Is that a true statement or is it a false statement? This is a true statement. The number of protons will always be the same as the atomic number. Now what about number 2? The mass number is the sum of the number of protons and neutrons. That is a true statement. Now what about 3? Isotopes are composed of the same element. Yes. In our first example, we dealt with carbon-12 and carbon-13. They were both of the same element, carbon. Isotopes have the same atomic number. That's also a true statement. Isotopes share the same mass number. That is a false statement. Isotopes have different mass numbers. Now what about number 6? Isotopes have the same number of neutrons. Is that true or false? This is a false statement. If the mass number is different, then the number of neutrons will be different as well. Isotopes differ in the number of protons. That's false. They have the same atomic number, and the atomic number is equal to the number of protons, so therefore they must have the same number of protons. Now what about number 8? Isotopes possess different chemical properties. Is that true or false? That is false. Because isotopes are composed of the same element, like carbon-12 and carbon-13, they have the same chemical properties. Their chemical reactivity is identical to each other. Now what about number 9? Isotopes possess different nuclear properties. That is a true statement. Because the number of neutrons is different and neutrons are found in a nucleus, the nucleus will behave differently. So therefore, isotopes have different nuclear properties, but they share the same chemical properties. So that's it for this video, and thanks for watching.